Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 8 learners. Welcome to today's Natural Sciences lesson. My name is Sianda Madlala, and this lesson is brought to you by the Gauteng Department of Education. Right. Today we are going to be doing the particle model of matter as our topic. And we have our subtopic, which is the concept of the particle model of matter and change of state. Also, these topics are found under the knowledge area, which is matter and materials for your term 2, which consists about 33 marks of your term 2. Now, let's move on. Let's look at what you need to achieve by the end of this lesson. So by the end of this lesson, you should be able to explain what is meant by the particle model of matter. Secondly, you need to be able to tell us or understand that particles of matter contain spaces between them, making reference to the concept of solubility. So we'll be doing some demonstration also on solubility. Thirdly, you need to be able to use the particle model of matter to explain the different characteristics that states of what? Of matter. Also, you need to be able to identify and compare properties of the three states of matter. And also, you need to be able to explain what is meant by the change of state. Lastly, you need to be able to describe the factors that affect the rate at which particles, which are your gases and liquids, diffuse. And all this information, we find it in the CAPS document on page 42. Right. Now, pre-knowledge. This is the knowledge that you have gone through and have done in the previous grades and also in the same grade. So we use such information as our foundation to build up on today's topic. Right. In grade 4, we have done materials around us. You still remember? We have done materials around us. And in grade 6, we have done the different states of matter. Also in grade 6, under different states of matter, we have done solids, we have done liquids, and also we have done gases. And another aspect that we have talked about is solubility. Right. In grade 8, we have done atoms as the building blocks of matter. You still remember that? Right. Now, here is a baseline activity. I want us to take about 5 minutes to complete this activity. But firstly, let's go through the questions together. So number 1, why is a fruit salad compared to a mixture and a chocolate cake to a compound? Then number 2, which diagram shows particles as a solid, a gas, or a liquid? Between these 3 diagrams here. Number 3, you need to state which of the following samples show an element, a mixture, and a compound. So let's meet again in 5 minutes after completing the activity. Welcome back, grade 8s. Right. Now let's be interactive, right? We have a WhatsApp question or WhatsApp interactive number, which is 082 760 2630. We can contact each other using this number, whether you have questions or answers to give to us, right? It's 082 760 2630. Now let's look at the solutions for our baseline activity. Right. The first question there, you needed to tell us why is a fruit salad compared to a mixture and a chocolate cake to a compound, right? Now looking at this cake and looking at this fruit salad, right? First of all, look at them deeply and tell us why this one, the fruit salad, is compared to a mixture and the cake to a compound. Now think of what makes up a compound. Think of the characteristics of a compound and think of also the characteristics of a mixture. So now the answer here for fruit salad. For fruit salad, it is because it does not require heat to be made. So there's no chemical change that is happening, right? It does not require any heat to be made. And also, there is no fixed ratio of the components of that fruit salad, right? As it says here, there is no fixed ratio of combination of substances, right? So don't forget to make yourself correct. And also, it is because the individual components retain their properties. The properties of the individual components do not change at all because there is no chemical reaction. Right, moving on. For the chocolate cake, it is because it requires heat to cook the ingredients, right? There is some chemical change that happens between the ingredients to bring about this chocolate cake. And also a ratio is required, right? And the cake does not resemble the ingredients. What do we mean? When looking at a cake as a final product, now you need to think of what made the cake to be that final product, right? It is made up of eggs, your vanilla essence, your milk, your flour, your sugar, and so on, right? But all the ingredients, looking at them one by one, they are different from the product, which is the chocolate cake. So meaning a chemical reaction and a change has taken place to bring about this chocolate cake as a product. Right, number 2. Which diagram shows particles as solid, liquid, or gas between the A, B, and C diagrams here, right? So now, which one is a solid, which one is a gas, and which one is a liquid? For your solid, we have A, right? It is A. Why do we say so? Look at the particles here, right? They are tightly pegged to one another, right? We'll talk more about that in our lesson. A gas, the answer is C. And also looking at the particles here, they are far away from each other. Then the liquid is B. This is because the particles are slightly away from each other, but not that much, right? Now moving on to number 3. You need to state which of the following samples show an element, a mixture, or a compound. This is between A, B, C, and D. So which one shows an element between the 4? Which one shows a mixture and which one shows a compound, right? Right. An element, it is A and B. Let's look at A and B, right? This is one element, right? This is one atom of an element. And also in B, you have what? Diatomic elements, right? So now the answer for an element is A and B. A mixture, what is the answer? The answer is D. Look at the substances here, right? They are all different, but they are not chemically bonded together. And a compound, the answer is C, right? We have different components or elements which are chemically bonded together. Right, I hope you have enjoyed this baseline activity, right? Now let's carry on. Let's look at today's important terminology. The first one there is solid. What is a solid? A solid is a substance which has a fixed shape that cannot be changed. And also, a liquid is a substance that can be poured and it takes up the shape of a container. We also have gas there. What is a gas? A gas is a substance that fills any space and cannot be seen, right? It cannot be seen with our own naked eyes. Also, state of matter is one of the distinct forms in which matter can exist. Solubility, right? Solubility is the ability of a substance to dissolve in water, right? So when you're talking about solubility, you think of any substance, right? And its ability to dissolve in water. We also have vibrate. What do we mean when we say something it vibrates? It means that it moves continuously and rapidly to and from. We have melt. When talking about melt, it means that it's when a solid turns into a liquid. Evaporate, it is when a liquid turns into a gas. Now condense, it is when a gas changes to form what? A liquid. And solidify, it is when a liquid turns into a solid. Lastly, freeze. That's when now we are taking what? A liquid and turning it into a solid. Right, now the particle model of matter. What is this particle model of matter, right? A particle model of matter is a model that is used to explain that all matter is made up of atoms or molecules. It is made up of those tiny particles which are atoms or molecules. So now, as it says here, the particle model of matter states that matter is made up of tiny particles that are constant and having a random motion. Let's look at this example here, right? Looking at this, right, you have tiny particles which are moving around, having that random motion, right? Meaning they can move freely anyhow and anywhere in this substance, right? And also their motion is constant, right? And also that the particle model of matter enables us to explain the properties and behavior of materials by helping us visualize what happens on a very small scale inside the materials. As we have viewed our examples here, right? It helps us visualize what happens in particles of matter as they are moving and having a constant what? Motion. Moving on. The model also helps us to explain what happens during physical changes. What are those physical changes? Remember, we're talking about what? Matter, right? And in our keywords or terminology, we have highlighted some of the physical changes. So we're talking about physical changes of matter from one state to another, right? So the model helps us to explain what happens during physical changes, such as melting, for one, condensation, freezing, evaporation, and sublimation, right? Those are your physical changes that happen, right? On matter. And also, the atoms and molecules are referred to as particles in the particle model of matter. Now, moving on. It is very important to note that the space between the particles is empty. Now we'll talk more about this space. So these spaces do not contain air and they contain absolutely nothing. So it means that they don't even contain air. So now atoms and molecules are referred to as particles in the particles model of matter. And here is the space that I'm talking about, right? In a substance, you have particles all around, right? Now, look at the spaces in between the particles. Look at the spaces, right? Here are the spaces, right? Look at all the spaces around here. So it means what? This space allows for movement of particles. They can move freely all around each other like that, right? In a constant and random motion. So now we have solubility there. We said solubility is the ability of a substance to dissolve in water. So we're going to do a quick demonstration on solubility. But first of all, let's look at what we need for our demonstration. What we need for the demonstration, we need a spatula, we need table salt, we need water and a glass beaker. Here is a picture of a spatula, and in terms of how it looks like, we have what? A glass beaker, and we have table salt. So who can guess what is going to happen here? We're going to check the solubility of salt in what? In water. So now let's just take 2 minutes to prepare, and we'll come back again after 2 minutes. Now, welcome back, grade 8. Here we are, ready for our demonstration, right? We said we're going to need what? A spatula, and we're going to need table salt, which I have here, and a glass beaker filled with what? With water. So we're trying to check the solubility of salt in the water, right? So I'm going to pour some salt into the water, and I want you to observe what happens, right? So now let's just stir a bit. Now notice that as you stir, the salt starts to disappear in the water. Who can tell me where is it disappearing to? Let's stir. It starts to disappear little by little, right? This is because the salt particles are absorbed in the spaces of the water particles, right? Forming a solution, right? Can you all see now, right? The salt has disappeared into the water. It is now a new solution because what? The salt particles have filled the spaces of the water particles. You can try also this demonstration at home, right? You can try it on your own and observe what happens. For now, let's go back to our lesson. Let me just give you a break for 1 minute. Now, welcome back, grade 8s. I hope you have enjoyed our little demonstration there, right? Please try it at home on your own, right? Just take your time and try the demonstration on your own to see and observe what happens, right? Don't forget, let's stay interactive, right? Our WhatsApp interactive number, it is 082 760 2630. Right, now let's move on. The 3 states of matter. Now let's remind each other, what is matter? We said matter is anything that occupies space and has mass. So meaning that this matter or anything that occupies space and has mass can be classified into 3, or it is in 3 states, right? As it says here, the properties and behavior of matter depend on the arrangement of particles. Particles are arranged differently in the 3 states of matter. So now, what are these 3 states of matter? Here they are, right? These are the states of matter. Matter can be classified into solids, liquids, or gases, right? And we said that all depends on the arrangement of particles. So let's look at the solids, right? Looking at the particles here, right? How are they? They are tightly packed, right? They are packed next to each other. They leave minimum space or no space at all, right? Looking at liquids, also the arrangement is different from the one of solids. Now look at the spaces here in between. Now there is some space in between the particles. So the particles have some little space in between them so that they can be able to move freely. Now when you look at gases, the particles are scattered, right? They are far away from each other, leaving lots of space. So there's a lot of movement of particles on gases. Now let's talk about them one by one. Right, first of all, let's do this activity for just 2 minutes. So it's 2 questions, then you get 2 minutes for answering. Number 1, it says, what is matter made up of? And number 2, you name the 3 states of matter. Before we continue, let's meet again after 2 minutes.
I'm gonna go to the toilet. So if I don't make it, then
We are allowing you to relieve
if
yourself.
I don't make it in time,
Right, welcome back, grade 8s. Now don't be tired, right? We use activities to test our understanding, right? So we're going to have more activities during this lesson, right? So now, number 1, it says, what is matter made up of? Matter is made up of what? All matter is made up of particles. What are those particles? Those are your atoms and molecules, right? Now, the three states of matter are your liquid, solid, and gas. So I hope you are marking yourselves correct for the correct answers and writing corrections where you need to write corrections. Right. Now, we said we're going to talk about the states of matter one by one. We said there are three, right? They are solids, liquids, and gases. So we're going to start off with solids. First of all, solids are found closely together. They are very close together and they are arranged in a definite regular pattern. Those are the particles of solids. They are closely together and they have a definite regular pattern. Also, there's some strong forces of attraction that hold the particles together. They keep them stable so that they vibrate in the same position, right? And also in a solid, particles vibrate in a fixed position and do not move to keep the matter stable, right? Also, here is a picture of a solid. This is an example of what? Of ice, which is a different state of water, right? Water comes in a liquid, it comes in gas, and it comes in solid. So when it is ice, it is solid. So meaning what? The particles of ice are arranged in such a manner. They are arranged that they are closely packed to each other, and also they have a regular pattern, as you can see here, right? They have some sort of pattern, and that pattern makes them to vibrate in a fixed position so that they do not move and to keep the ice as solid, right? Also, solids, there are very small spaces between the particles, as I have said, right? There are very small spaces between the particles. And also, therefore, they have a definite shape and maintain their shape of fixed volume, right? So that little space or no space between the particles, it is the one that gives off the shape of that matter or the ice that we talked about. Also, they are not compressible, meaning you cannot change their shape, right, as you apply pressure on them. As you can see, here is another illustration of the arrangement of the particles. They are closely packed, and here is an example of a solid. Now, the solids that we know around us, for example, are your toys, right? Those are solids because their particles are arranged in a regular pattern. They vibrate in a fixed position, and also they don't move so that they can be able to maintain the shape and the fixed volume of the toy. Here's an example here of which you know the pens, right? Pens are also examples of solids because they are not compressible and also they are strong, right? Now let's talk about liquids. So liquids is a different state of matter as well, right? So in a liquid, but now in a liquid, the particles are loosely arranged, right? They are not tightly packed to each other. They are loosely arranged, but still quite close together, right? They are still quite close together. So now, meaning what? There are weaker forces of attraction between the particles than in a solid. So that weak force is the one that allows for the movement of particles freely. Also, particles flow freely over one another because of the space that I'm talking about, the space between the particles. So looking at this, so this particle can move in this direction, this one can move in this direction, this one in that direction. They are free to move around. This is because of the space around them, right? Looking at this space, right? There's lots of space here between the particles. So that's why the particles are free to move around. And that, as a result, is the one that gives the motion for water, because the particles of water are able to move around freely. So also, particles of liquids, they move faster than those of what? Of a solid. So now, typical example, when you pour water on the floor, it flows quicker compared to just putting ice on the floor, right? So now, liquids therefore do not have a definite shape. Also, they take the shape of the bottom of the container, and it has a fixed volume but can flow, and it is also compressible. Now here is another example here of the particles having some space and being able to move freely. Right, this is another example that you are familiar with. When you pour tea into your cup, right? As you pour tea into the cup, the tea is liquid, right? As the tea is liquid, it takes up the shape of the cup as a result. Here's another example here. When you pour in water into the bathtub, it takes the shape of the bathtub. This is because of what? Their particles have some spaces, allowing the particles to move freely, and also they are not compressible and have a fixed volume, right? And lastly, they do not have a fixed shape. So now, let's talk about gases. Gases, the particles are found far apart. They are scattered from one another. And the spaces between the particles is much larger compared to solids and liquids. So there's more movement now. There's more movement of particles because now there is vast amounts of space. This is because there are very weak forces between the particles. So it allows the particles to flow freely over one another. As you can see here, there's lots of space. So the particles can move freely over one another. There's a lot of movement here, right? Around these spaces. And also gases, their particles move faster than those in liquid state and solid state. Then the gases therefore do not have a definite shape. They will expand to fill any container. They also take up the shape of a container. Now looking at this example here, right? Look at these spaces. There's a lot of movement of these gas particles, right? Now let's look at this example. This person here is blowing a balloon, right? I also have a balloon here right in front of me, right? So let's look at when you blow air into the balloon, right? Air is a gas, right? Let's try and see. Now, can you see? It takes up the shape of the balloon, right? But as you allow air to pass throughout, the particles start moving out quickly, right? They fill up the spaces in the air around again. So now let's move on. Activity 2. This one also I'm going to give you 5 minutes to complete. So you have this table. You just need to fill in the arrangement of particles for solid, liquid, and gas, movement of particles for solid, liquid, and gas, effect of attractive forces between particles for solid, liquid, and gases, then the space between particles for solid, liquid, and gas. Let's meet again in 5 minutes. Welcome again, grade 8s. Now, don't sleep, grade 8s. We still have this WhatsApp interactive number, which is 082 760 2630. Contact us for your answers or any questions that you may have. For now, let's look at the solutions for our activity. You had to complete the table below and compare the particles in solids, liquids, and gases, right? So you needed to write the arrangement, movement, effect of attractive forces between particles, and also the space between the particles for solids, liquid, and gases. Now the arrangement for solids, they are closely packed towards each other, right? They are packed closely together and arranged in an organized pattern. Let's look at for liquids. For liquids, they are randomly or loosely arranged. And for gases, they are not arranged in any specific way because of that large amount of space. Now, movement of particles. For solids, the particles vibrate or the movement is slow. For liquids, they can move freely than in solids. Then for gases, they are more randomly around and spread out to fill the spaces. Now the effect of attractive forces between the particles. In solids, they are held together strongly. And in liquids, they are not held as strongly together. Then for gases, the particles are not held together strongly again. Now let's look at the spaces between the particles. For solids, the particles are close together, leaving no space, right? And for liquids, the particles have larger spaces in between them. And for gases, they have very large spaces between them. Now I hope you got your answers correct and you have written the corrections or corrected the incorrect one. Now let's move on. Now let's talk about the last two parts now. The second last part here is change of state. What do we mean change of state? What are we changing state here? We're still talking about what? Matter. We're changing the state of matter from one to another. So now, substances exist in three forms, right? In solids, liquids, and gases. So that's the state that we're talking about, changing from solids to liquids, from solids to gases, gases to liquids, liquids to gases, and so on, right? So we need to look at the processes involved in changing the states there. So now, for example, the one example that you know, water, when it freezes, it becomes what? A solid ice. When it melts, it becomes liquid. And when the liquid is heated, it becomes a gas as it evaporates, right? So now let's look at the processes involved. So now, to change the state of matter from solid to gas, there's a process called sublimation, right? As you can see there, we use sublimation to change what? A state of matter from being solid to a gas, and also reverse sublimation from changing it to from gas to solid. And also you can change a solid and melt it, and then it becomes what? A liquid. Also that liquid can be frozen to become a solid. You can also change a liquid to gas by heating it, and via evaporation it becomes what? Gas. And also you can change a gas to a liquid using the process of condensation. Right, now play along with this, right? Play along with this and familiarize yourself with this so that you are able to understand the processes involved in the changing of the states. Right, so now when heating or cooling, this can cause what? A material to change state. We use particle model of matter to explain what happens to the arrangement of particles when the state changes. So let's look at this example here. When you move from solid to liquid to gas, there's some adding of energy. What do we mean by adding energy? We use now the process of what? Of heating, right? As it heats, it what? It heats and the particles have more energy and they start to move apart from each other. Hence, you see here, in the solid state, they are tightly packed towards one another, right? So as it moves from solid to liquid, now the particles start to become loose or far away from each other. This is because now they are more excited during that heating process. As you heat more again, they move further apart from one another and they change from liquid to gas, right? Look at the particles now. They are far away from each other. They are very much scattered. But now, when cooling, you do what? You decrease the energy or you remove the energy. They start losing energy now from gas to liquid and they come close to one another slightly and slowly but surely, right? Then from liquid, they start coming closer to one another more to form a solid. Right, now diffusion. What is diffusion? Now the particle model of matter also explains diffusion, but what is diffusion? Diffusion is that movement of particles from a highly concentrated area to an area of low concentration, right? As it says here, diffusion is the process in which particles in liquid or gases move or separate and spread from a highly concentrated area to an area of low concentration, right? Here is an example here. Now looking at this structure here, the particles are highly concentrated here, right? This is where we have an area of high concentration. So we're saying diffusion is the movement of particles from where they are highly concentrated to an area where they are of low concentration. So now as they move or spread around, right, they are moving to parts where there is less concentration of those particles. So now as you can see now, the particles are scattered here all around this space from where they were highly concentrated to filling up the whole space where there is low concentration. Right, let's use a practical example for diffusion in gas. When a perfume is sprayed in one corner of a room, so we're all familiar with that one, right? When you spray that cologne in the morning, it only smells around you up until a certain time, right? So now, at first, you will not smell the perfume, right? We're talking about the next person now. So here is a perfume spray. As you can see there, we are spraying the perfume and the area of concentration is right here. It is highly concentrated here, right? So these particles will move now or diffuse to an area where they are lowly concentrated. So at first you will not smell the perfume, then the gas particles from the perfume then gradually begin to move and separate so that you can have the air particles all around the space. So now, from that small corner of your room to the whole house, right? Or the whole room. So now it moves from a highly concentrated area to an area of low concentration. Now, diffusion in liquids. Let's look at this example first, right? Can you see that there is water and there's some food coloring or a liquid being poured into the glass of water, right? Look at what happens, the next step here, right? There is some dilution of liquid happening. It becomes more here and it becomes a new color here. So what happens? We're going to use food coloring in water as an example. So when the food coloring is first dropped into the water, the particles are concentrated in the space. This is what I was talking about, right? From this drop to here, right? This is where the food coloring is highly concentrated, right? Up until it starts spreading because of what? The loose arrangement of particles in a liquid. Now they start fusing with each other, right? Then you have this spreading. the food coloring spreading into the water up until it becomes a new color like this. So it's because of the loose arrangement of particles in a liquid, and also the particles of food coloring can flow into the spaces between the water particles. Then the particles of food coloring will gradually spread through the water until they are evenly dispersed, as we can see this new color here, right? Right. Now let's talk about the rate of diffusion in liquids and gases, the speed in which diffusion takes place. Right. We say that diffusion is faster in gases as compared to liquids. Why do we say so? Because the particles of a gas are wider apart and move faster than the particles of a liquid. Let's look at this diagram here. Looking at the gas particles, can you see the movement, right? It is very fast because of the air spaces around, because of the spaces around or between the particles, right? They move freely and they move in a faster speed. Looking at the liquids, there is small space around the particles of a liquid. Hence, the movement is slower than the ones of gases. So this makes it easier for the particles to move from one point to another because of the space in between the particles. Now, the last activity, activity 3. This one I'm going to give you 2 minutes only 2 minutes to complete. You need to define diffusion, and number 2, you tell us in which medium, air or water, does the substance diffuse faster. Then you give a reason for your choice. Let's meet again in 2 minutes. Welcome back, grade 8s. Are you sending those answers to our WhatsApp number, which is 082 760 2630? Right, let's look at the solutions. Number 1, you had to define diffusion. And we said diffusion is the process in which particles in liquids and gases move from an area of high concentration to an area of low concentration. I hope you got that correct. We also said that the medium in which air or water does substances diffuse faster, right? So which one? It is air. Why are we saying it's air? This is because the particles of a gas are wider apart and move faster than the particles of a liquid. And because of the forces between the particles of gases are weaker than in liquids. Right, moving on, let's summarize what we have learned today. So we said matter is made up of tiny particles that cannot be seen with our naked eyes. We also said that we can use the particle model of matter to help us understand the movement of particles and molecules in the matter and to see how they behave, right? So we can use the particle model of matter to understand how matter behaves, how particles are arranged and move, and also what happens to particles when matter changes between gas, liquid, and solid state. We talked about this diagram, right? We said solids, their particles are closely packed to one another. As for liquids, they start to be loosely packed, right? They are loosely packed from one another, allowing some movement in the spaces, right? Then gases, we said that there's vast amount of space which allows for more movement or quicker movement. So we also talked about diffusion, right, between gases and liquids. And we said diffusion is the process in which the particles in liquids and gases move from a high concentrated area to an area of low concentration, right? So we're comparing diffusion of gases and liquids, right? We said that gases, as you look at this diagram here, they move around quickly to fill up the spaces or around the spaces, and liquids, they move slowly because they have small amounts of space. So we made an example using your perfume for the diffusion for gases, saying that it only smells in that corner or one corner of the room up until a certain time where the particles spread throughout the room. Right, now here is our home activity. Now I'm giving you time to copy the activity, then let's conclude this lesson. So now let's read questions first. Number 1, what is the property of a solid? Number 2, melting is the change in the state of A. Number 3, you give one word of matter that can flow and does not have a specific shape. Number 4, you consider 3 phases of matter illustrated in the diagram below. Then you describe in detail the arrangement and behavior of the particles in a gas. So now, thank you and goodbye.